Hey guys, what I'm working on here is I've been shrinking some of my projects down playing with these ATTiny85 microcontrollers. Here's a full-blown Arduino Uno, and sometimes, like my MP3 project, you only need a few pins, so there's no use in using a Uno or a Mega or a Leonardo or any other Arduino development board, or building one with a large ATmega chip. All I need is one or two LED pinouts and software serial. So the ATTiny package supports the Arduino IDK, all the libraries, same instruction set. It does not have hardware serial, but you can configure the pins for software serial. So pin 1, the dot designates pin 1, that's your reset. Pin 2 and 3 are Arduino pins 3 and 4. They can be used for digital I/O or analog A to D. Pin 8 is ground. And then on the other side, these 3 pins can be configured for digital I/O, pulse width modulation, or analog inputs. And then VCC is on pin 8. So if you want to make your own little programmer and use a Arduino as the programmer, which I'm going to do in a minute, and I'll step you through that. I've kind of got wired up, but I made this little board last night because I have several of these that are ordered, and I just want to go ahead and program them all at one time with a blink sketch, just a basic sketch, so that at least the bootloader and everything's in them. They have an internal 8 megahertz clock. When you burn your first blink test code to it, you set the fuses are set at 1 megahertz, but to use software serial you'll need to burn the bootloader afterwards, and I'll show you how that's done later, and get it up to the full internal 8 megahertz clock. So what I've done is I've just made a little IC socket for a DIP8 package, and it's got the pinouts. It's just got male pin headers to go to the programmer. It just takes 3 lines to talk to it: power, ground, and a reset line. I've also added the LED for the blink sketch. Very simple. And I added a cap for the reset line, so you no longer have to bridge a cap across your programmer. You just simply connect your reset line to this last pin right here, which I have disconnected at the moment. So what I need to do now is, first of all, here's how you wire it up for the ATTiny. Very simple. You can see the orange is your reset line, goes to pin 10, and 11, 12, and 13 on the Uno, as you can see, just go to pins 5, 6, and 7, and give it power and ground. So now that we've covered that, let me bring up. I've got my Arduino Uno connected, but I need to set it up as a programmer. So to do that, I'm going to open the Arduino development. Go to, first of all, make sure your board and your COM port are set for your programmer. I'm using an Arduino Uno. There we go. Serial port, that's correct for my setup. Okay, so now what we want to do is go to File and go to your example sketches and choose Arduino ISP. Now upload this to your make sure everything's right. Yeah, everything looks right. It has pinouts for the Mega board too if you need to change those pins. So everything's already set up. I'm going to upload it. Okay, programmer's done. Now what I'll need to do is, now that it's set up as a programmer, I can reconnect my reset disable, which is just strapping this cap. See, that connects that cap to ground so that it doesn't reset, and I just got to go into my reset line. I do need to hook up power. Let's see, my purple wire is ground and my blue wire is 5 volt. So if I can do this while filming, this is my power, and get this pin on my ground lead. Okay, now all I need to do is put my chip into the IC socket, and then we can proceed to program a basic blink sketch. And like I said, initially you'll have to do this at 1 megahertz, but if you're going to use this thing for software serial, you'll need to burn the bootloader, which will set the fuses to run at the full 8 megahertz. And by the way, you can, I'm not sure how, but you can externally clock these up to 20 megahertz. So let me get the chip inserted and we'll pick up from there. Okay, so my chip is now inserted and everything's hooked up. I've got the reset disable line hooked back up. There's one more thing you need to do with these chips. I have mine set up already, but unless you've downloaded the board information for the ATTiny chips, when you look under your board selection, you won't see it. The first thing listed will be Arduino Uno. As you can see in my list, I've got all the variations of the ATTiny, and to get that, I'll provide a link in the description box. You let's see, where's it at? Right on this board, on this page, there's a link to the boards.txt. And anyway, what you do is you download that, and then let me get to my Arduino folder. Once you download that, you go to your Arduino folder and you put the contents in your Arduino hardware directory. You just dump the ATTiny right there, and that puts the board information for all the switches. So there's the board variants and the boards.txt. So you'll need to do that, and I'll provide that link. So now we're set up as a programmer. So to send one last thing to do to set this up as a programmer, it's already got the Arduino ISP sketch on the Uno, but you still need to go under Tools and Programmer and set it to Arduino as ISP. Okay. Now, since we're using an ATTiny85, I'll have to change my board from a Uno to the AT chip that the ATTiny that I'm using. So what I'll do now is I'll open up just the basic Blink sketch, examples, basics, Blink, and you'll need to make one little modification. Instead of pin 13, you need to change this to pin 0, and that equates to, on the IC, that is pin 5 on the IC, but to the software it's pin 0, which is, I've got my LED on pin 0. Wasn't worried about a resistor because, well, this thing's not going to overdrive it. But you could put a 680 ohm resistor if you wanted to. So we've modified our pin number. I can close this other sketch. One last thing to do before we try to upload this is to go under Tools, go to Board, and I have the ATTiny85, but for your first burn you want to choose the internal 1 megahertz clock, and then later we'll burn the bootloader after we get the Blink sketch uploaded. And that burning the bootloader will allow us to run it at full 8 megahertz, which gives us not only a faster chip, but it's required for software serial. So if I hit upload and I did everything right, then hopefully we'll have some success down here. So let's hit upload. Okay, I don't see any errors. Let me double check. But however, I do not see my LED blinking either. But it could be some bad soldering. And I may have to do some double checking. So let me do that and I'll be right back. Okay, so the problem was, as I read on a forum, I didn't think it would matter, but I had to take the LED out of circuit, and all the steps before, now the Blink sketch is on here now without error, but I'll have to make a jumper so that I can take this LED in and out of circuit. It needs to be out of circuit when you go to program it. Not sure why, but I guess it puts a load on the MISO pin, which is the white wire right here going to pin 5. So now that that's on there, to enable software serial and get it running at 8 megahertz, everything stays the same except go to your board, change your board, instead of 1 megahertz, change it to 8, which I've already done, and then go to Tools, burn bootloader, and I'm hoping it does this without any errors. And the bootloader is in there. Now all that did was set 3 fuses to basically tell it to use a different divisor. So now instead of this running off of a 1 megahertz clock internally, it's running 8 megahertz, and now I can use software serial. And so now that this is set up, these are factory ATTinys that are not programmed. So basically all I gotta do is pop this chip out and program the other three the same exact way. For now, what I'll do is I'm going to resolder. I'll be back in 1 second. Let me resolder this LED, and we should have some kind of output just to verify. Be back. Okay, so I got all that working. Until I get a jumper. I did add a resistor, but I don't have 2 pins handy, so I'm just going to leave that out of circuit, that LED. I just put a fresh chip in. I've got 2 more to go right there. So another factory chip, same setup. This is still set up as a programmer. So got the blink sketch again, double check my board. ATTiny 1 megahertz. Serial port check, programmer, Arduino is ISP, it all looks good. Upload, and hopefully no errors. And it's done without any errors. Great. Now, back to tools. Time to burn the bootloader and set the fuses for an 8 megahertz clock. So change your board back to 8 megahertz. And tools, burn bootloader, and we shouldn't have any problems. May have to reset the chip, so let's try that. I'll just unplug this. Let's see, I'll unplug the power. Okay, power, reset. Yeah, I probably had to reset that chip. Everything else is the same. Wiring's still good. Okay. Let's try to burn this bootloader again. That was it. Yeah, you got to do a reset. No problems that time. So burn your blink sketch at 1 megahertz clock. Reset. Change your board to 8 megahertz, and then do your bootloader. And that was the problem there. I just needed to do a reset. And since I have the cap preventing an automatic reset, the chip could not reset itself, so I took care of that. Anyway, that's how you do it. All you need is 2 rows of pin headers. I gave myself an extra pin, so I used 5 pins, and 1 IC socket, 1 resistor, 1 LED, and a 10 microfarad cap or larger will suffice. This is a little low. I think this is 100, but anything over 10, polarized, of course. Anyway, I hope that's helpful. I'm going to program the rest of these.